everyone, this is Elizabeth Phillips. Today I'm going to go over a couple of simple math problems. We're going to begin by discussing sets and whole numbers, number theory, and last but not least, numerations and computations. Now I know this sounds scary, it's a bunch of big words, makes your brain hurt. It's actually very simple. If you'll just follow along with me, we'll go ahead. We'll walk through it, make sure everybody gets everything, and we will rock this out. So we are going to go ahead and we're going to start out by discussing Venn diagrams and the elements of U. And for question 1, we are presented with a Venn diagram with circles A, B, and C. And if you'll notice, there are some spots where the circles overlap. There will be some letters in these spots. Those actually correspond to the overlapping circles, showing what is shared among them and what isn't. Again, and here, I'll go ahead and we are going to get our screen right on just so that we can kind of go along with this. If you will notice at the very top right there where I just drew my arrow in that big yellow box, we are presented with, and let me just fix this just so that this makes sense to us. Those are actually supposed to be upside down U's. Apparently, it didn't go through quite like I wanted it to in the presentation. Now, if you'll notice in this yellow box right here, we have a UB, and then we have a NB. Now, we're going to kind of go over these. These are just actually very, very beneficial notes to help us solve for all of these questions right here. So we'll go ahead, we'll start out with AUB, which means objects that belong to set A or set B. And just a quick example of this, if we look at our Venn diagram and we look at circles A and B, we pretty much want to find the objects that belong to set A or set B, which means we don't want anything shared between them because those shared letters are going to be the AND part of the notes, which we'll go over here in just a minute. It might sound a little confusing right now. So if we'll look at where the circles overlap, just those two circles, we'll notice that we have, let me get this moved over here. We have this section right here where they overlap. This is actually our AND part of the equation, which means that D and H are shared. They're not either or, they're AND, which means they will not be a part of our solution. Now, when we look at circles A and B, we'll notice that we have B, C, G, and F. All 4 of these are going to be a part of our solution because they are either in the A circle or the B circle. They are not shared between the two, which means that our solution for AUB, we'll kind of get this where we can see our letters. Our solution for AUB is going to be B, C, G, and F. Now, if we look at our second part of the notes, we'll notice that we have A and B, or the inverse of our U. And this basically represents objects that belong to set A and B. It's that shared section that I was just talking about between 2 corresponding circles. So just to get our little example going, and I'll go ahead and erase my little notes. We're going to take a look at our Venn diagram. We have circle A, we have circle B, and we want to find this overlapping section where our letters are shared. And all of the letters in this section are actually going to be a part of our solution to this problem. So if we'll look in our section, our overlapping section, we'll notice that D and H are both letters in this. Now what we want to do is we are pretty much going to draw our bracket, and we're going to put D, we're going to put H, and since those are the only 2 letters in this section, this shared section between the 2, we're actually going to close our brackets right there, and that will be our solution for the problem. Now we're going to go ahead. We're going to start out with problem number 1, which is B, U, C. And if we just go back and we look at our notes, we will actually notice that we are looking for objects that belong to set B or set C. Now, or is the big word in this statement because we are actually looking for the letters in the shared, or not in the shared section. We do not want the letters in the shared overlapping section between the two. We want the letters in either B or C. So we'll go ahead, we'll take a look at B, C. We do not want any of the letters in the shared section again. So D and H will not be a part of our solution. In circle B right here, we actually have an F. And in circle C right here, we have a G. Therefore, our solution is actually going to be FG. Put FG, close our brackets, and that's our solution. So for this next problem, we're presented with A, N, B, which is going to be the complete opposite of B, U, C, our last problem. With A and B, if we just look back at our notes, we'll notice that we're really needing to find the objects that belong to set A and B. So that's basically going to be our shared overlapping section between the two circles. If we'll look at our Venn diagram and identify the section between A and B, we'll notice that this purplish gray section right here is actually going to hold all of our solutions because it is a part of A and B. Therefore, D and H will be a part of our solution set. So we'll go ahead and do our brackets. We'll put D, H, and that'll be our solution for this problem. For the next problem, we are presented with B, N, H. Now, we know what N means. When we have an N or an inverted U in a problem like this one, we know that we are looking for objects that belong to the first circle and the second circle. So in this instance, we're looking for objects that belong to B and C. In other words, we're looking for the letters in this overlapping section right here that belong to both circle B and circle C. Therefore, our solution is going to be D and H. D and H. Now, at this point in the video, I encourage you to go ahead and pause, take a moment, just kind of look at the remaining problems and see if you can solve them. If not, it's okay. Just keep watching. Pause whenever you feel comfortable. And just go ahead and rock on. And whenever you are ready, unpause the video and follow along with me, and we will go over everything that you did. Now for problem 4, and actually we want a new fresh color. In problem 4, we are presented with A, U, C, and we know that the U in this problem represents the either or section of our notes. So when we go and we look at, and we're going to erase this real quick, that's in the way. We are going to look at circle A and circle C. And since we're looking at either or, we're not looking for the shared letters among the two. So all of the letters in our shared overlapping section will not be a part of our solution. Therefore, we'll go ahead and look at circle A, and we actually have B and C, and we'll look at circle C, where we actually do not have anything. So our solution for this set is going to be B, C. For problem 6, let's get us a new color. Do some purple this time, some different purple. we're looking at A, N, C. Whoops. And we'll actually notice that the N in the problem represents the AND portion of our notes, which means we are looking for the shared overlapping section in order to find the letters in it to complete our solution. Now, if we just take a look at A and C, we'll notice that we have an overlapping section right here among the two, and we have the letters G, H, and D, which will actually be a part of our solution since they're shared between A and C. So we'll go ahead and do G, H, D, and now for our final problem, and I know this one looks a little tricky. It's actually not quite too bad. We're just going to go ahead. We'll switch our color to, we need something exciting. Somewhat exciting. We'll do a dark green. It stands out, kind of. We're looking for objects, and we're going to break it down kind of like PEMDAS. We're going to look at our parentheses first. We have a B, N, C, and when we have an N, we're basically looking for objects that belong to set A and B, or not sets A and B, B and C in this case. So we're going to look at problem B, problem C, and we're wanting to find the problems or the letters in this section right here where they are shared. And now we're going to analyze the second part of our problem right here, AU. And we are going to look at our set of notes. We know that U means either or. So for this part of the problem, we want to, and I'll switch that color so it stands out. We want to find the letters in either A, right here, or our section right here. And the thing about this, if you actually were to kind of look at it, from all of our problems so far, whenever we're presented with our U or our OR portion of the notes, we never take the letters out of these shared overlapping sections. So that's going to be the same case in this problem. Actually, if you look at circle A, it goes around like this. If you look at circle, or not circle, but our section that we took from B and C, we've got this right here, and we know that we cannot use the sections where they overlap, which means D and H will not be a solution to our problem. Now, in order to find the solution, we need to look through our selected areas, and we need to circle off our problems that are not in the shared section, which would include B, C, G, and we have no letters in this section right here. Therefore, our solution will be B, C, G. And that will be the end of question number 1, guys. Really not too hard once you kind of understand the concept of U and N. Feel free to go back, watch this video over again if you need to. Don't be afraid to use the notes. The notes are actually very, very beneficial when it comes to solving problems such as these. So we'll go ahead and we are going to move on to question number 2, where we will discuss Venn diagrams and shapes. Again, our image looks slightly intimidating just because everything's everywhere. It's actually not as bad as it seems. Now, in order to solve for this, and we're going to go ahead and we're going to fix these blank spots. I'm not sure why they're not popping up. TNR. C, N, S, N, R. All right, I think we are all set as far as that goes. Now, if we look at our key in the bottom right corner of the problem, we will notice that we have letters and their representations right next to them. So we have S for our small shapes, R for our red shapes, B for our blue shapes, and L for our large shapes. And don't forget your note from the last slide, which actually I may try to pull up right here real quick. Let me get that there. We're going to pull it over here just so that we kind of have something to look back on. Yeah, that works good right there. And we are just going to get rid of that circle, do our screen right. Now if we look at our note from our last problem, we have our AUB, our ANB, NB, and it's just the same concept except without, or with this problem, you actually have more of a visualization of the images kind of to help better understand the concept of U and the inverse U or the N. So if we'll look at our first problem here, let me fix this. I'm not sure why these aren't popping up in our problems. They are being strange. If we'll look at our first problem, we have LNH, which means that we need objects that belong to set L or H. And I believe I forgot to, oh no, I did not. That key at the bottom right corner only covers the colors and the shapes. There are actually other letters that represent other things. So for example, H would be hexagon, which is going to be our shapes with the 6 sides. And then we have C, which is going to be our circle. And then we have T, which is going to be our triangle. Now when we look at our problem, we have LNH, which means, and if we kind of break this down, we know that L would mean large shapes, and H would mean hexagons. Now if we look and compare large and hexagons, we look back at our notes, we'll actually notice that we're looking for objects that belong to set A and B. So large hexagons. Now, the fun thing about writing the solution for this is it's actually very simple. We don't have to put a U, we don't have to put an N or anything like that. We just make a quick, simple phrase. So if we have large shapes and hexagons, it's safe to assume that we're going to have large hexagons. Now for problem number 2, we have CUH, which means we need we need objects that belong to C or H. C or H. So we know, if we kind of look at our key up here, we know that C is for circles. We know that H is for hexagons. So it's safe to assume that our answer will be circles or hexagons. And this is because the U represents the OR part of our notes, which is objects that belong to set A or set B. So our answer for this one is going to be circles or hexagons. And we're going to circle our answers right there. For our next one, we know that T is going to be triangles and R is going to be red. We know that our N represents objects that belong to T and R, or triangles and red. So it's safe to assume that our answer is going to be red triangles. We'll circle that. And for our last equation, we have a slightly bigger one. It's actually really not that bad. It's pretty easy. We have C and S and R. We're going to switch colors just to have something a little different. Let me think. We want this color. We know that C is equivalent to circle. S is equivalent to small. And R is equivalent to red. Now we know from this that we are going to have red circles or small red shapes. So red circles or small red shapes. And that's the end of our second problem. It's actually very simple, very easy to follow along with. So we're going to go ahead and we are going to work on our third problem, which is Indo-Arabic equivalents. They may seem scary. There are a bunch of different images, things that you might not have seen before. It's actually very easy as long as you follow along with the key and mark your progress as you go. So for our first problem in this question, we are presented with the Egyptian system. If you'll notice, we're given different shapes. Let me get my screen right on so that we can see. We're given these shapes, which will be a pointing finger. We're given these shapes, which are yolks, and then we're given these shapes, which are staffs. And if you'll kind of notice, each one is given a different number to kind of represent how much it is. So just to break this problem down, we're given 3 of our pointing fingers, and 1 pointing finger is equivalent to 10,000. So what we're going to do, since we have 3, we're going to do 10,000 3 times. 10,000 and 10,000. And when we add 10,000 3 times, we're going to get a total of 30,000, which is going to be the first part towards working toward our answer for the entire equation. Now in the second part, we're presented with 5 yolks. As you can tell just from looking at the key, 1 yolk is equivalent to 10. And since we have 5, we're going to do 10 times. 10 plus 10 plus 10 plus 10 plus 10. And when you add 10 5 times, you're going to get an equivalent of 50. For our last part of the problem, we're presented with 4 of the staffs, and 1 staff is equivalent to the number 1. So if we add the number 1 4 times, we get a solution of 4. And now to find the final solution of this problem, all we're going to do is add 30,000, 50, and 4, which you can go ahead, throw in your calculator. You can do mental math. Me personally, I'm going to go ahead and I'm going to do my calculator. 30,000 plus 50 plus 4 is going to be 30,054. Now for our next problem, we're going to go over the Roman number system, and they actually do theirs a lot differently. They don't use images, they use letters. I'm sorry about that. They use letters. So if we'll look at our key, we'll notice they have M, D, C, L, X, V, and I, and each one represents a number in the system. So we're going to go ahead and we are just going to start out with the letter M. And if we'll look at our problem, we'll notice that we have 2 M's. Now, in order to find out what number that is 2 M's are equivalent to, we just look at our key. We have M at the far right, and we have the number 1,000 as its equivalent. Since we have 2 M's and each M represents 1,000, we're just going to add 1,000 to itself twice, and our solution will be 2,000 for that problem. Again, we'll do the same thing with C. If we look at our key, we notice that C is going to be equivalent to 100, and we are presented with 1C. Therefore, C is going to give us 100. Again, we'll look at our problem. For our next one, we'll do X. We're presented with 3 X's in our problem, actually. So we go up to our key. X is equivalent to 10. And since we have 3 X's, we're going to do 10 plus 10 plus 10. And when you add 10 3 times, you're going to get a total of 30. Next, we'll move on to V. We know that V is going to be equivalent to 5 since it is actually, or it's in the key. And we're only presented with 1 V in the problem. So our solution has to be 5. We have 5 total points for V. For the last one, we're given an I. We're actually given 2 I's, and if you'll look in the problem or the chart, you'll notice that 1 I is going to be equivalent to 1. Well, if we add I, sorry about that. If we add I or 1 twice for the total number of I's that we do have, we will notice that our solution for that one is going to be 2. And when we add all of this together, in other words, 2,000 plus 100 plus 30 plus 5 plus 2, we are actually going to get the solution of 2,137. Now for our next problem, this one is definitely strange. It's actually a set of shapes that represent different numbers. And all we're going to do is we're going to look at our problem. We're given 4 of the arrows to the left and 1 of the upside down triangles. And in our, since we don't have a chart, in our wording that we have at the top of our problem, we realize that an upside down triangle is going to be equivalent to 1, and a left arrow will be equivalent to 10. Since we have 4 of our left arrows in our problem, we're going to multiply 10 by 4, and our solution should be 40 for that one. Again, with our triangle, one triangle represents 1 point, or the number 1. We only have 1 of those in our problem. Therefore, 1 times 1, since we only have it 1 time, is going to be 1. And when we add all of this together, and we do 40 plus 1, we'll find that our solution is going to be 41. Now with the next problem, this one is probably the most difficult just because there are so many images going on. In our next problem, we're going to be studying the Mayan number system. And in order to find a solution to a problem for the Mayan number system, we have to track down the shapes, write down the numbers, create a problem, and add them together. Sounds like a lot right now, but it's actually very, very simple. So for our first part of the problem in our orange box, we have a straight line. And I'm going to get my screen right going on just to do that. We have a straight line, so we go through, we look through all of our images. I'm sorry about that. We look through all of our images, and we will notice that we have a straight line right here. And one straight line is going to be equivalent to 5. So we'll add that to our equation. The second part of our problem in the purple box, we have a line with 1 dot on top. So we look through our problem. Well, the next box has the same image, the one right after our first one. And that one says that it's worth 6 points. So we're going to go ahead and add 6 to our problem. And we're going to move on to our third part of the equation, which is our red box. In this box, we're given 3 dots, which at the beginning of the Mayan number system, we'll notice is right here. And we will notice that 3 dots is going to be equivalent to the number 3. And then in our final part of the problem, we're given 3 lines with 2 dots. And near the end of our Mayan number system, we'll actually notice an image like this right here. And its equivalent is going to be 17. So in order to solve for all of this, you're welcome to do mental math. You're welcome to write it out. I'm actually going to use a calculator for time purposes. We go ahead, we add through all this together. We have 17. We have 6. We have 3. And we have 5. Which means our solution should be 31. Again, this is very, very simple. As long as you have a key or something to reference to that'll help you, it's very simple to solve for these problems. Now, and let me get it off of this. For our next problem, we're going to go over lattice multiplication. This, I promise you, is probably one of the scariest looking ones that you'll have to go through as far as our work goes. It's actually one of the easier, more fun problems as well. So if we go ahead and we take a look at our next problem, we are given the problem 28, or multiply 28 by 35 using the lattice algorithm. Now, if you'll notice, I went ahead and took the liberty of setting up our box. Whenever you go and do, and here we might actually make a slide right here, just to kind of get an idea. Whenever you go to make a lattice algorithm. All you're really going to do is you're going to draw a box. Forgive my art. Let's say you are given the problem multiply 22 by 11. Well, you have 2 digits in the first part, or the first number, and you have 2 digits in the second number. So you can split your cube down to the middle so that you have one here and one here, one spot there and one spot there for a number. And then you can split it across and you'll have a spot here and here for a number. And all you're going to do is put 22 and 11, and then you're just going to split your boxes in half like this. And again, I'm sorry for my art. It's not the best. We'll go over our problems as well. This is just kind of to get a broad generalization of how to do this problem and how to set it up and so on. So if we'll go ahead and look at our first square, which I'll switch out this color just to make it a bit easier to follow along. Our first square right here, we have 2 parts. That's meant for 2 digits. Whenever we go to solve this problem, we'll notice that 2 times 1 is going to be 2. So we'll put a 0 right here and a 2 right here. For our next box, we'll notice 2 times 1 is again going to be 2. So 0 here, 2 here. And then for our bottom right corner, we're going to do another 2 times 1, which is 0, 2. And then for the last one, 2 times 1, which is 0, 2. Now, in order to solve for 21 times 11, we are actually going to go down this way, and we're going to add all of our numbers up until we get the correct answer. So in this column, we have a 2, so that's going to be 2. In this column right here, we have 2 2s, so that's going to be 2 plus 2, or 4. For the third one, we have a 2, and for the final one, we have a 0. So in the end, our solution to 22 times 1 should be 242. All right, now let's begin with our first problem in question number 4. Our problem that we're given is going to be multiply 28 by 32 using the lattice algorithm, which is basically what I just went over, except this is going to be a neater, not quite as messy, not example, but a easier, not quite as messy problem right here. So I went ahead and took the liberty of drawing our square, and I put down the numbers 28 and 32, and we're just going to walk through this together and solve for 28 times 32. So if we'll look at our first square right here, we're pretty much going to find 8 times 3. Now 8 times 3 is going to be 24. And all we're going to do is put the first digit, 24, right here, and the second digit right here. And that's it for that part. So the next part, for our upper left hand square, section of our square, we have 2 and we have 3. Now 2 times 3 is going to be 6. So we're going to put a 0 right here, and we're just going to put our 6 right there. Again, we'll get our bottom right square, and we will be doing 8 times 2, which 8 times 2 is going to be 16, so we'll put 1, 6 for 16, and then 2 times 2 times 2 is going to be 4, so we'll put a 0 right here, a 4 right here, and that is it for the first step of the lattice algorithm. Now for the second step, we're going to go ahead, we're going to add everything this way like I said last time, and we're going to write our numbers down here in these blanks. I will say one thing, whenever we get a number that is more than 10, we get to do something special in order to solve for that, and I'll go ahead and go over that whenever we get to that point. But starting out, we have our 6. Since we don't have anything to add to it, to our 6, we're just going to write our 6 right here and go to the next area. We have a 4, a 1, and a 4 in this next section. That arrow is not very good. We're going to go ahead and add 4 plus 1, which is going to be 9. And then for our next section, we're given a 6 and a 2. We're just going to do 6 plus 2, which is going to be 8. So we'll put our 8 down here. And our last section has a 0, so it's simply going to be 0. Now comes the fun part, because you don't have to do any math for this step. You just put a bunch of numbers together and you get your answer. Simply put, you can put your numbers in order like that, and you can do 0, 8, 9, 6, or you can remove that 0, and your solution should be 896 when you multiply 28 by 32. And we'll go ahead and we're just going to put this over here in our answer box. And that will be the solution for 28 times 32. So for our next part of our problem, and this is where we're going to encounter a couple of 10s, where I get to show you what I was talking about for our last problem. Let's get our screen right going. In this problem, we are multiplying 273 by 628. So this is just going to be the same process as our last problem. We're just going to go ahead, solve for each individual square, and we're going to put the digits down like we're supposed to, with the first digit in the upper left-hand corner of the box and the second digit in the lower right-hand corner of the box, or the section that you're working on. I'm going to go ahead and I'm going to switch colors just because this is purple. Let's actually do some pink. I think that's a little exciting. And we'll go ahead. We're going to do 3 times 6, which 3 times 6 is going to be 18. So we're going to put 1, 8. Then for our middle section of our top row, we have 7 times 6, which 7 times 6 is going to be 42. So we're going to put a 4 and a 2. And then for our upper left-hand corner of our puzzle, we have 6 times 2. Very simple. It's just going to be 12. We'll put a 1 at the top, 2 at the bottom. And now we're going to move on to our second row. We're going to start at the rightmost section, where we have 3 times 2, which is going to be 6. So we're going to put a 0 here, 6 here. Again, for the middle one, we're going to do 7 times 2, which you can type this in your calculator if you like. That's actually what I'm doing right now. You can do some mental math. That's also what I've been doing. You can write it out. Anything that makes you feel comfortable and helps you solve the problem, I am more than open to you doing. So for 7 times 2, it's going to be a 1 and a 4, 14. For our leftmost box of the middle section, we have 2 times 2, which is going to be 4. So 0 and 4. And for our last row in our box, in the rightmost corner, we have 3 times 8, which is going to be 24. We have 7 times 8 in the middle section, which is going to be 56. And then we have 2 times 8, which is going to be 16. Now, this is where the fun comes in, because we get to add all of these up. So you remember, you're going to add like this, and you're going to go by line. So for our first section, all we have is a 4. And we're going to change colors real quick. So we're going to go ahead and we're going to put 4 right here. Our next section, we have a 6, we have a 2, and we have another 6. This is where the fun part comes in. So whenever you go to add 6, 2, and 6, you're going to get the number 14. We only want one digit as a result of our addition. So what we're going to do is we're going to take 10 out of that. We're going to take 10 out of that. And here, actually, let's go ahead. We're going to write that in red. We're going to take 10 out of our 14, and we're going to move it over here, and it's going to turn into 1. And that will be a new number to add to our next row. So since we took 10 out of our overall solution, we will have 4 as a remainder, and that will be what we write at the bottom. For the next part, we have 3 1s, we have a 4, nope, I'm sorry, I skipped ahead 1. For our next part, we have a 6, we have a 5, we have a 4, we have an 8, and then we have our 1 that we brought over. And when we add all of this together, we get 24, which is too much. We need one digit. And since we have 24 and we're in the 20s, we can go ahead and we can subtract 20 out of that. Sorry, that's not quite red. We're going to subtract 20 out of that, and we're going to add 2 to the next row. And as a remainder, after taking out 20 from 24, let me fix that. After taking out 20 from 24, we are going to have a remainder of 4, which will be a part of our solution. So for the next part, we're given 3 1s, we're given a 4, a 2, and then we have our 2 that we brought over from our last column. And we'll draw an arrow right here. And when we add all this together, we're getting 11. Again, that's not one digit, so we're going to take 10 out of it. And when we take 10 out of it, we're going to put a 1 over here for that 10. And we will have a remainder of 1 that we're going to write right there. For the next part of the problem, and I'll draw my arrow, we're going to have a 2, we're going to have a 4, and we're going to have a 1, which means that our solution is going to be 7. Well, that's a one-digit number, so we don't have to do anything special. We can just go ahead and write our 7. Now for our final part of this problem, we actually only have a 1. We don't have to add anything, so we can go ahead and drag our 1 over here. And since we did that, we will officially have our solution. The best way to get that is to just write our blue numbers, our final numbers, in order from this direction, which means that 273 times 628 will be 171,444. Now we're going to move on. We're going to go to our third part of the problem. And we're just going to go ahead and we're going to solve for this. Get my screen right up. In this problem, we're presented with 964 times 593. And we're going to do the same thing that we did last time. I'll pop a new color on there just to have a little fun with it. If we look at our upper rightmost corner in the first row, we will notice that we've got 4 times 5. Well, 4 times 5 is going to be 20. Again, in the center, we have 6 times 5, which is going to be 30. In the upper left-hand corner of our problem, we have 9 times 5, which is going to be 45. Which that did right as well as I'd wanted it to. We're going to try it one more time. That is a much better 4. For the next part in our middle row, starting from the rightmost section, we have 9 times 4, which 9 times 4 is going to be 36. And then we have 9 times 6, which is going to be 54. And then 9 times 9, which is going to be 81. For our bottom rightmost corner, we have 4 times 3, which is 12. We have 6 times 3, which is going to be 18. And then we have 9 times 3, which is going to be 27. So now what we're going to do, since we have all of our sections filled out and we know what we're doing, we are going to go ahead and we are going to solve 964 times 593. So starting out with our first row right here, all we have is a 2. Therefore, all we have to do is write our 2 at the bottom. With our next row, we have a 8, a 1, and a 6. 8 plus 1 plus 6 is going to be 15. Well, we don't want 2 digits. We only want 1 digit. So we're going to take 10 out of that, and we're going to move it over, and we're going to label it as a 1 for our next digit up. And then the remainder, once you take 10 out of 15, you're going to have 5 left. You're just going to write your 5 right there. For the next part of our problem, we have 7 plus 1 plus 4 plus 3 plus our 1 that we transferred over earlier, and our solution is going to be 16. 16 is a 2-digit number, and we only want a 1-digit number, so we're going to subtract 10 from that, and we're going to move it over to the next row and just pop it down as a 1 for our next digit up. And then all we really need to do after that is write our remainder, which is going to be 6. And I apologize for that. I wrote that 1 too high up. We're going to go ahead and put our 1 right there. And there we go. Now for the next part, I'll do that. Our next column right here, we have, and let me get my calculator back up. It's acting strange. For our next part, we have 2 plus 1 plus 5 plus 2 plus our 1 that we transferred over. And our solution is going to be 11. That's a 2-digit number. We want a 1 digit, so we're going to subtract 10, and we're going to move it up over to the next area, the next row, and we're going to label it as a 1. Now after that, we write down our remainder, which is 1 over here, and then we move on to that next row, where we will add 8 plus 5 plus 3 plus 1, and our solution for that one will be 17. Again, it's a 2-digit number. We want a 1 digit, so we're going to subtract 10 from that, and we're going to move it to the next row and label it as a 1 for the next digit up. And then we just write our remainder right here, which is 7. And then we add the next row, which is this one right here, which 4 plus 5 is going to be 5. That is a 1-digit number, so we can just go ahead and write it down. And then we just write our digits down in this order, and we will have our solution. So our solution for 964 times 593 is going to be 571,650. All right, guys, so now we're going to go ahead and we're going to start out with rounding with division, which is going to be question number 5. Our first problem is going to be 883 plus 45 divided by 134. If you'll kind of look at my screen, I actually went ahead and I took the liberty of creating the rounded problem, which we'll go ahead and we'll figure it out in the next one. I'm going to kind of explain how you find that. But just to start out, we're going to go ahead and we're going to solve for our original problem right here. And then we're going to solve for our rounded problem. And we're going to compare our answers. So just to start out, and I'm going to use my calculator for a little bit of this just to let me think, just for time purposes. You're welcome to do it by hand if you like. We're going to go ahead and we're going to do 883 plus 465 just to simplify our division problem. And when we do that in our calculator, 883 plus 465, we will get 1,348 divided by 134. You can go ahead, you can write this out, do your division tables like that. 1,348 by 134. I'm going to go ahead and I'm just going to do my calculator just to kind of save on time a little bit. So we're going to go ahead, we're going to start out and do 1,348 divided by 134. And you're going to get a very long answer. It's going to be something like 10.597014925. Round it to the nearest 10 or hundredth. Just round it to the nearest second digit or third digit. I'm actually going to do my answer as 10.06 because our original answer 10.059 in our original answer, you'll notice that the 9 is 5 and above. It's actually it's 9. So we can go ahead and we can round up this next digit to our 6. Now, since we know that our solution is 10.06, we can go ahead and write that up here, 10.06. That's going to be our true solution. Now we're going to go over our rounded problem. And I'm just going to do a quick run through. The easiest way to make your rounded problem is to round to the nearest leftmost digit. So it's the same with our decimal, how we rounded up from 10.059 to 10.06. When we look at our problem here, we have 883. We'll look at our digit right here, our 8, and we'll look back a digit. If the digit to the right of it is 5 or more, we can go ahead and round that up to the next hundredth. Now, if the digit, say instead of 883, we were given 823. Well, when we get our 8 and we look at the digit right next to it, to the right of it, the 2 is actually below 5, so we would have rounded it to 800. But since it is above 5, we can go ahead and call that 900. Again, if we look at our next problem, or our next number, we have 465. A quick and easy way to just kind of round this is to look at our 4, our leftmost digit, and then look at the number to the right of it. 6 is 5 or more, so we're going to go ahead and round that up to 500. For our next one, 134. We're going to get our 1, our leftmost digit, and look at the number directly to the right of it. 3 is actually below 5, so we're going to round down to 100, the nearest hundredth. And that is how I got this rounded problem right here. Now we're going to go ahead and we're going to go for our next problem, which is 620 times 430 divided by 293. You're welcome to work this one out as well. You're welcome to pause the video as well and just kind of go over the problem on your own and see how well you understand it, and to see, kind of challenge yourself, just see what you do know, what you don't know. If you need to unpause the video just to kind of get a better grasp of what's going on. As far as this problem goes, I actually just did 620. Whoops, I don't have my screen right on. That may be beneficial. We have 620 times 430, which is going to be 620 times 430, 266,600. And now we're just going to do 266,600 divided by 293. But you can work it out if you'd like. I'm just going to go ahead and write it or type it in my calculator. And my solution that I got is 909.897. Since 7 is above 5, we can go ahead and round this 9 up to the nearest number, which is 10. And in this case, since it's 10, we can go ahead and move over another digit, add that 1 from our 10 to our 8, and we should have 909.90. So we will write our answer, our solution, up top next to our original problem, equals 909.90. And now we're just going to do a quick run through of how we got our division problem, and we're going to solve that, and we are going to compare our answers. So for 620, we're going to look at our leftmost digit, our 6, and then look at the number directly to the right. Since 2 is below 5, we're going to round to 600. Our next number, 430. We're going to look at 4, look at the digit to the right of it. 3 is below 5, so our number that we're going to round to is going to be 400. And then 293, our next number, is going to be 300, because when you look at our leftmost digit and the one directly next to it, our 9 is above 5. Therefore, we're going to round up to the nearest hundredth, and it will be 300, which is how I got 600 times 400 divided by 300. Now we're just going to solve for that one. You get a new color. All right, so you're welcome to, again, do this by hand if you'd like. I'm going to do it by my calculator for time purposes. 600 times 400 is actually going to be 240,000 divided by 300, which is going to be 800. Now, as you can see from our rounding, we were close to our actual solution, but unfortunately, we were about 800 off, or not 800, 109.9 off, which we'll do this, 109.9 off. Which, rounding our division problems in order to solve them. This is a great way to get close to the solution that you're looking for, but at the same time, it can be risky and you can be off by this much. You will be close, but you will be a little bit off. All right, for our next section, we're going to talk about charts and transitions. For question number 6, we're going to start out with A, and we are going to have 432 plus 133. Now this chart looks a little bit scary. It's actually very, very, very easy. The best way to fill it out would be to put 432 in this row right here and 133 in this row right here. Now we know that for our first row, for 432, we have a 2 in our ones place. So what we are going to do to solve for this problem is we are actually going to put 2 dots right there, and that will represent our 2. Now for our next one, in our 10th place in 432, we have 3. So we are going to have 1, 2, 3 dots. For our 100th place, we have 4. Therefore, we are going to have 1, 2, 3, 4 dots right there. And since we have nothing in the 100th place, we are going to go ahead and we are just going to leave that blank for now. And we're going to move on to 133. So for 133, we have a 3 in the 10th place. Therefore, we're going to put 1, 2, 3 dots. We have a 3 in the 10th place. So we're going to put 1, 2, 3. And we have a 1 in the 100th place. So we're going to put a 1. Now, the best way to solve for this, let me go ahead and just check something real quick. The best way to solve for this would be to add going down. So for our first column, or our rightmost column, we have 2 dots in the first section. We have 3 dots in the second section. We're going to add 3 and 2, and we should get 5 dots all together, which we'll write our 5 right here. For our next column, we have 3 dots up top, 3 dots at the bottom, and when we add 3 and 3, we get 6. Well, there's something wrong with this. At the very top of your chart, right here where this 5 is at, this 5 is telling you that you can only have, whoops, I apologize. I believe I misread that. I'm sorry. We're going to go ahead and add 3 plus 3, and we will have 1, 2, 3, 4, 5, 6 dots all together. So we'll put our 6 right here. And then for our final column of dots, we have 4 up here, 1 right here. 4 plus 1 is going to be 5. So we will have 1, 2, 3, 4, 5 dots in total in that bottom row, which means that our solution, as far as adding 432 and 133 goes, will be 565. Now for our next chart, we're being asked to add 425 and 53. Now this is going to be the same process. We're just going to go ahead. We'll do this right here. Get a purple dot this time. And we're just going to do 425 right here and 53 right here. And we're just going to do what we did last time. In 425, we have 5 in the ones place. So we're going to do 1, 2, 3, 4, 5. Put our 5 right there. For our tens place, we have 2. So 1, 2. For our hundredths place, we have 4, so we're going to do 1, 2, 3, 4. And now we're going to move on to 53 since we don't have anything in the thousandths place for 425. So for 53 in our ones place, we have 1, 2, 3. In our tens place, we have 5, so 1, 2, 3, 4, 5. And for our hundredths and thousandths place, we actually don't have anything, so we're not going to mark anything down. Now in order to find the solution, we can start out with our ones place, and we're going to add by the column. For this column, we're going to do 5 plus 3, which is going to be 8 altogether. So we're going to have 1, 2, 3, 4, 5, 6, 7, 8 dots all together, which we'll actually put down here, 8. For our second column, we have a 2 and a 5, so it'll be 2 plus 5, which means we'll have 1, 2, 3, 4, 5, 6, 7 all together. Put a 7 down here as well. And then for our final column that we have filled out, we only have 4. We don't need to do any addition. We'll drag our 4 down. 1, 2, 3, 4. And we will have 4 at the bottom. And once you get done with this, we realize that 478 will be our solution when it comes to 425 plus 20 or 53. I hope you guys learned something today, and I hope you had fun kind of following along with me. If you happen to not get anything, feel free to go back, rewatch the video, ask me questions in the comments. Anything is open, and I hope you guys have a fantastic day.